All right, welcome back. Today we're looking at 5.6 logarithmic and exponential equations. So these next two lessons are going to wrap up our exponential and logarithmic stuff. We are trying to solve here for our variable. Some of them are pretty easy. Other ones are going to be a little bit more difficult, but we're still using the properties of logarithms in order to solve these problems. All right, so for the first one, notice the log bases are the same. So what we're going to do here is kind of like we did last time. We're going to take anything we have out in front. We're going to apply that to our value. So in this case, we have x. We're going to say this is log base 5 of x squared equals log base 5 of 9. So right, step 1, numbers in front of logs become exponents. Okay, next step. Notice that we have log base 5 and log base 5 of here. If these two things are equal, then x squared's got to be equal to 9. So this is an easy one, right? We just clean it up a little bit, and we know that x squared has got to be equal to 9. And then we're going to solve this. So remember, anytime we take the square root of a number in Algebra 2 and higher, we have to remember that we have a positive and negative. Square root of 9 is 3. Right? We know that because 3 times 3 is 9, but also negative 3 times negative 3 is 9. Okay, next one. Notice this one doesn't have the log base on both sides, so we're going to have to solve this a little bit differently. What we're going to do, though, is we're going to apply the properties we were using last time to simplify, right? So we have this addition here, and we have the same log base on the same side. So what we're going to do is combine that into one log. And we said that anytime we have an addition, that's like multiplying. So x plus 6 times x plus 2 equals 1. All right, and again, we have the log base 5 on the left side, but not the right side. So we can't just say right now that x plus 6 times x plus 2 is equal to 1, right? But what we can do here is, so write as one log. Should make that look like a log. Okay. Step 2, because we don't have the logs on both sides, we're going to rewrite this as an exponential. So remember, the base is 5, right? It's always equal to the exponent. So we can say 5 to the first power, right? Because that's what log means, right? We can rewrite the log as an exponent is equal to x plus 6 times x plus 2. So rewrite as an exponential. And we practiced that earlier in the unit. Okay, once we have this, we're just going to simplify this stuff up. So I'm going to FOIL here, right? We're going to distribute. 5 to the 1 is 5. So we have 5 equals x times x is x squared. X times 2 is 2x. 6 times x is 6x. And then 6 times 2 is 12. Right, if we're solving this, let's simplify first. And keep in mind, you guys can skip steps if you're good at it. All right. Anytime we're solving an not an exponential, but a quadratic, we're trying to make it equal to 0. So remove the 5 over. 0 equals x squared plus 8x. 12 minus 5 is positive 7. All right, and then we're going to factor it. So we have x and x. We're looking at what multiplies to get 7, adds to get 8. That would be 1 and 7. And then we're going to use our zero product property, right, to finish this off, because we know that if we have two things multiplied together and they equal to 0, then one of them, if not both of them, has got to be equal to 0. So negative 1 plus 1 is equal to 0. negative 7 plus 7 is equal to 0. So those are our values for x that make our statement true, our equation true. Okay, so a lot of steps. Most of it is just algebra stuff though, so you guys should be good at it. The last one is actually a little bit easier than the one we just did, I think, just by looking at it. And it's easier because we have the ln's on both sides. So the first thing we're going to do is we're going to combine these ln's into one. So we have ln x times x plus 4 equals ln x plus 6. Okay, so at this point, I guess we can do this inside part. So we're just going to distribute that x. So ln x squared plus 4x equals ln x plus 6. All right, and because we have the same log on both sides, we have ln, which, just a refresher, means that we have base e there. It's like log base e, right? Just to remind ourselves what ln means. Then we can just say if this ln of this thing is equal to ln of this thing, then those two things, x squared plus 4x, has got to be equal to x plus 6. Okay, and again, when we're solving this quadratic stuff, we got to make sure it's equal to 0, right? The quadratic means that we have x squared. So let's move the x and the 6 so that we can have 0 on the right side. So we have x squared plus 4 minus 1 is 3x minus 6 equals 0. And maybe it's not that easy because this doesn't factor, right? There's nothing that multiplies to get negative 6 and adds to get 3. So what we're going to have to do here is we're going to have to bust out our old friend, the quadratic formula. Negative b plus or minus square root b squared minus 4ac over 2a. Our a is 1, our b is 3, our c is negative 6. So we have negative 6. Careful with your signs. Negative 6 squared minus 4 times 1 times negative, times, I'm using the wrong numbers here. Geez, b is 3, I just said it. Okay, so let's redo this. Okay, so negative 3 plus or minus square root of 3 squared minus 4 times 1 times negative 6 over 2 times 1. So then let's simplify the whole inside if we can. So 3, and then negative 4 times 1, negative 6, that's 24. So 9 plus 24 is 33 over 2. And then that will be it. Okay, so I guess good practice that in case we haven't used the quadratic in a while, to remember that if we get stuck, we can't factor, we can always go back to the quadratic formula. This should be the old, trusty, faithful one, right? If you get stuck, go back, use the quadratic. That's it for today, guys. Please let me know if you guys have any questions for next class, and we can go over them then. Otherwise, good job.